Hello everybody, welcome back to part 3 now of the 2.3 notes about functions and relations. There's just a lot of material here, but I want to try to get through a couple of topics. We have this idea about the intercepts, the x-intercept and the y-intercept. We're going to talk about these, and then we're also going to talk about domain and range in this video. But there's not much to it with x and y-intercepts. You know, what it's referring to is the fact that whenever we graph one of these kinds of functions that just has two variables, rather the function itself has one variable. What I'm talking about is that there's an x and a y variable to make a two-dimensional axes, x and y. Whenever we graph it, it's going to intercept the x-axis potentially, the graph will. That will be called the x-intercept. And something that we know about the x-axis, all y values are 0 along the x-axis. Every point that's along here, the y value is 0. And that's actually how we'll find the x-intercept of something. You just set this f of x, which this is a y value. Whenever you plug in x and you get something that's called f of x, like you get the corresponding y value for that x value. And in particular, we want to find the x value whenever that y value is 0. So we just make the y value be 0, and then we solve this equation for x, and we will end up having the x-intercepts. And so here we have to just, there's a couple of ways that we can do it. The way that comes to mind for me would be to actually factor this one. Adding 4 to both sides is okay. But we can factor this one x plus 2, x minus 2. I want to show this one just because this here, of course, this is a difference of squares, and it's a special type of thing that we can factor, difference of squares. Of course, the reason why it's called a difference is because it has minus, and then the reason why it's squares is because this is like x squared, and then minus 4 is also something squared. 4 is 2 squared. So both things are squared, it's minus, so it becomes difference of squares, and then whenever we factor it, we just do x plus 2, and then also x minus 2. So that's a really nice one, and then here we can split this up into two different equations. We can make it go x plus 2 is 0, and also x minus 2 is 0. So then x is negative 2, or else x is 2. And we will end up getting two different x-intercepts, 2 and negative 2. And so if you're wondering why did I split it up into two equations, it's because here we have multiplication of something. It's going, you know, this thing times this one. It's a multiplication, and we end up getting 0 as an answer. That's only possible if one of the two things or both of them are 0. So we say, well, this product can be 0 if x plus 2 is 0. It also can be 0 if x minus 2 is 0. And then we will end up getting those two those are the x-intercepts. Now we need to find the y-intercept using kind of the same idea, which is that all along the y-axis, for all of these points that are on the y-axis, all of the x values are 0. And so what we would do for ours is we just need to plug in 0 this time. We'll say f of 0 is, in this case, 0 squared minus 4. And since we're plugging in 0 for x, whatever we get as the y value, that will be the y-intercept. And so f of 0, which is the y-intercept, is 0 squared, which is 0 minus 4. 0 minus 4 is negative 4. So this is the y-intercept. These ones were the x-intercepts over here, negative 2 and 2. Y-intercept is negative 4. And it probably would be more appropriate to actually write them as the ordered pair. Like say that the x-intercepts are negative 2, 0, and 2, 0, and then that the y-intercept is 0, negative 4. That maybe would be a little bit more principled, and so we'll go with that one. And so that's how we will find x and y intercepts. You just set the things equal to 0, and you're good to go. Now I'm going to just go straight straight away, I understand that this problem about absolute values might be a problem, and so I just want to look at this one as far as at least the x-intercept is concerned. We're going to have a couple of those. So I'm going to just draw this kind of a line to separate this work there. And we can talk about this one, number 7. We're trying to find the x-intercepts. Means the y value needs to be 0, so 0 is 3 minus absolute value of x. And then we're solving for absolute value of x, so I just want to add that to both sides. To me, it looks better because now it will say absolute value of x equals 3. And so whenever you're solving absolute value, you take a look at what is inside, which in this case it's just x, and you take that thing and you say that x is equal to 3. And then you can say, or that same thing should go here again. We have this another case of like making two equations. Or we say that x is equal to, in this case, negative 3. You put the negative of what is on the other side of equals. And so those will be the x-intercepts for this one. The y-intercept, it will go very straightforward because g of 0 is just going to be 3 minus the absolute value of 0. Which is 3 minus. The absolute value of 0, of course, is just 0, because absolute value means you just make it positive. And 0 is already, it's actually not positive or negative, so it's kind of a funny one, but absolute value of 0 is just 0. And so the y-intercept will be 3. And so x-intercept, I will write the answer, actually there were two of them again, the answers are negative 3, 0, and 3, 0. And then for y-intercept, the answer was just 0, 3. So that does it for that one. And now we will have a chance to take a look at domain and range here. And domain and range, it can be a little bit difficult if we are actually dealing with the equation. But whenever we have a picture, what we're looking for, of course, the domain, remember, the domain is the set of x values, and the range is the set of y values. And so one of the things we're going to have to pay attention to on these graphs is where these arrows are. Like this arrow over here means it's just going on forever. But you see, if it's going on forever in this direction, it's going forever up and also to the left. So it always, along this x-axis, if we're kind of tracking it like as we move to the left, see these x values are going this way, and it's never going to stop because this arrow just keeps going. The same reason, you know, if we're just following along these x values that are possible, it's never going to stop. It just keeps going on and on to the right. And so if we think about along the x-axis, what is ever going to be underneath this graph? That's kind of what I was doing. I was looking at the graph and looking at what is going to be underneath, which x value will be there. It's actually all values. The domain is every value of x. Every value of x will be underneath this graph at some point. And so the domain, we can write this a few ways. We can say that the domain is just all real numbers. That's what this one means. It's supposed to be like a bold-faced capital R. This means all real numbers. We also could write it another way. We can write it in this thing called interval notation, which goes negative infinity to infinity. This one, interval notation. And then there must be another way to write it with kind of this, I'm not sure how exactly you'd want to call it, but you can say x is anything in between negative infinity and infinity. These would all be equivalent to each other. I think that the first two that I wrote would be preferred, but we're especially going to be interested in the interval notation. This is the one that's going to be very common for us. And so that is how the domain will be found for these. And again, we're just looking at the graph and just seeing to the best of our sensibilities what's going on. And so to find the range, we need to figure out for this graph, what are the y values that this graph will ever achieve? And you can see the smallest y value that will ever be there is the value of 2. So basically y, it's always going to be greater than or equal to 2. And then it's just going from 2, and it's just keeps going up forever, these y values that are possible. So it can go up like it's going towards infinity as well. So this will be our range. But like I said, we would prefer interval notation. And so I will make a couple of notes about interval notation here, but we would write it as it goes from 2 to infinity. And so basically, I will just write here for interval notation, it has a relationship with the inequality like I wrote, where basically, if you use the brackets, like we go from A to B, bracket means that it includes the value. If something goes, maybe it goes from A to B and then we put parenthesis, parenthesis means does not include that value. Oops, does not include the value. And so that's why whenever we have infinity on there, you have to use parentheses always. Does not include that one. We have to use parentheses whenever we're talking about infinity because infinity is actually not a number, so there's no way that you could include it. We need to not include infinity because it is not a number. And so that would be the domain for this one. And we're going to do them kind of all the same way. I hope that it's clear what we're doing with this one. Maybe we can look at this example number 11 just because it's somewhat interesting. And here I want to pay special attention to the fact that there's no arrow here, it's just a point. And so actually, when we're thinking about the domain, which x values are possible, obviously since this arrow is just going forever to the left, then the domain, it's coming from negative infinity. And then it's going. I'm just drawing these x values. It keeps going. And then it stops because there's this hole there. It means that the function actually does not include that point. But then it picks back up on the same point, so it doesn't ever exclude that x value. And then it just keeps going, but then actually it does stop there at 4. And it's a closed circle, so that means it includes that point. And so it goes up until 4, like that one. And then for the range, you see the range is supposed to be the y values that are possible. And all along this first segment over here, all of these points along here have the same y value. They all have a y value of 1. And so only the y value of 1 is being contributed there. But then from this point, basically on the graph, I'm meaning for that to be an arrow, it's going to include the value of 2, the y value of 2, and then it's going up, and then it stops there. And so because of this segment, we end up getting all of the y values that go from 2 up until 3, 4, 5, 6, 7, up until 8. So the range it's going to have, and here we will see a notation. If you just want to have one value by itself, then that was not the ultimate curly brace. We want to have a curly brace like this one. It has the value of 1. Like we were talking about, the value of 1 is coming from this horizontal part. And then we will say union, because we want to attach just this solitary value of 1. I will say solitary value goes inside the curly braces. And then the union means that we just want to attach that set to the interval, which it's okay to do it. We will attach it to the interval that goes from 2, and it includes 2 because 2 is there, 2 up until 8. And that's the range for this one. And so we do have one last bit of stuff to talk about with functions, and we'll pick that one up in the next video. But thank you guys for watching.